Hello, good morning. Your friend and teacher, Mr. Esomnof Chidebube from Community High School Ibariam is here again to take you on revision class, which will prepare you for your forthcoming external examinations like the NECO, NABTEB, and even GCE. This program is sponsored by the Executive Governor of Anambra State, Chief Willie Obiano, initiated by our Honorable Commissioner for Basic Education, Professor Kate Azuka Omenuya, and coordinated by Mr. Patrick Okeke of PPSC Oka. Now, we are going to extract questions coming from your previous past questions on NECO, NABTEB, and GCE because WAEC has already been taken. So we should not be unmindful of the fact that there are other external examinations that are facing us, that will face us in no distant time, which are the NECO, the NABTEB, and GCE. So this class is basically to prepare you for this forthcoming examination. In this lesson, we shall extract questions that will come from. So for this class, we are going to focus on questions that has already come out on sequences, indices, and the logarithm. This will be the center of our concentration in this class. So we are picking questions that have come out in NABTEB, NECO, GCE, but our center of attention should only be focused on sequences, indices, and logarithm, so that in other lessons we shall focus on other topics. So the essence of this is to prepare you so that before your examination we must have covered a lot of topics that you require to write your exam and excel. Okay, so look at this first question. This question is from Indices, because when you talk about indices, it deals with power. You can see powers here. So this is coming from Indices, and this is NABTEB 2015 past question. So this question is from NABTEB 2015 theory. Okay, a theory question from NABTEB coming from Indices. And remember that indices are just the plural of the word index, which means raised to power. So the idea of solving indices is to ensure that you make all of them to have either a common power or a common base. For instance, we have, so this is what we are having, 8 power of 3x multiplying 8 power of minus 1 equals 32. So you know that this 8 can be written as 2 power 3, because when I raise 2 to a power of 3, I will get 8. That is to say, 2 times 2 times 2 times 2 into 3 times will give us 8. Don't forget your 3x, which is your power, multiplying, seeing 8 again, I'll write 8 as 2 power 3, because 2 power 3 is still 8. Don't forget your minus 1 equals, seeing 32, I will call it 2 power 5, because if I raise 2 to a power of 5, I will get 32. So the idea is to make all of them to have a common base or a common power. Now, 3 times 3x will give us 9. So we shall have 9x here as a power, times 3 times minus 1 will give us minus 3. Okay, so this is now 2 power of 5. Remember, from the laws of indices, whenever you are multiplying, simply add their powers if they have common basis. So we can add the powers as 2 power of 9x plus minus 3 here equals 2 power of 5. Now remember, when you see plus and minus in between two numbers, you are taking minus. So we shall have 2 power of 9x minus 3, because plus minus is minus, is equivalent to 2 power of 5. At this stage, you are free to cancel their bases because it is common on both sides. So I've cancelled the bases. I'm left with 9x minus 3 equal to 5. So I have here 9x minus 3 is equivalent to 5. So this minus 3 will cross over, it will change to plus, which I now have 9x equals 5 plus 3. Because minus 3 coming to the other side will turn to plus. So 9x is equivalent to 5 plus 3 is 8. Now to get rid of this 9, I will divide both sides by 9 to get x. So divide by 9, divide by 9. 9 cancels out. I'll have that x is just 8 all over 9. And that's just the answer to that question. NABTEB question theory 2005. So let's take another question now. Alright, so the second question for today is still on indices. Once we exhaust indices, we go to another topic, either sequence or logarithm. So here we have 4 power of 3x over 2 is equivalent to square root of 8 power of x all over 4. This one is from NABTEB 2008. So this question came out from NABTEB 2008. Let us see the analysis and solution. So when you have 4 power of 3x all over 2 is equivalent to square root of 8 power of x all over 4. Now, this is 4 and 8. You know that all of them can be expressed as powers of 2. So this 4 here can be written as 2 power of 2. 2 power of 2 will give us 4. Then 3x over 2, you shouldn't forget this power, is equivalent to, remember from the laws of indices that the square root of any number means that number power of half. So this can be written as 8x, then power of half, because of the square root. That's why I'm putting power of half. All over, seeing 4 can be written as 2 power 2, because 2 raised power of 2 will give me 4. Now, these 2 can cancel out these 2. We shall be having 2 power of 3x only at the left-hand side is equivalent to, now x times 1 is x all over 2. So this will now be 8 power of x over 2 all over 2 power of 2. Now let's complete from this side. I can say write my left-hand side as 2 power of 3x is equivalent to 8 can be written in powers of 2. So this 8 can now be called 2 power 3, then to a power of x over 2. Because 8 is the same thing as 2 power 3, because 2 power 3 is 2 times 2 times 2. And when you multiply 2 by itself into 3 times, you must arrive at 8. So that's why I'm having 2 power 3 representing 8 over 2 power of 2. Now, this is the same thing as 2 power of 3x equals 2 power of 3 times x is 3x all over 2 over 2 power of 2. Now, since they're having the same base now, and this is division sign, whenever you have division, it means you are going to subtract their powers. So you are not wrong if you write that 2 power 3x is equivalent to 2 power 3x over 2, then minus this 2 that is here, because both of them are having a common base and division is taking a place. Now, these 2 can now cancel these 2 because they are common. You are now free to write that 3x equals 3x all over 2 minus 2. So we should solve this resulting equation. But if I were you, to get rid of this 2 that is here, because working with fractions most times confuses a lot. So to get rid of these 2, multiply both sides by 2 so that these 2 can be cancelled out. So multiply everything you are seeing in this equation by 2 to cancel out these 2. So when I times 3x by 2, I will get 6x equals, if I times this by 2, look at what I will have in 2 is multiplying 3x all over 2 minus 2 times 2 will give me 4. So that these 2 will cancel out these 2. And I have that 6x equals, what is left here is just 3x, then minus 4. So this 3x will come to this side, it will turn to negative. You have 6x minus 3x equals minus 4. 6x minus 3x will give us 3x equal to minus 4. So to get the value of x, I will divide both sides by 3. So if I have over 3 here, 3 cancels out. So x will give us, this is an improper fraction, so we need to move it to a mixed fraction. 3 into 4 is just negative 1 over 3, because 3 times 1 is 3 plus 1, you get back your 4. So this is just the solution to this NABTEB question. So let us take another one. Okay, so here the third question for today is still from NECO GCE 2019, still on indices, and this should be the last question on indices. We go to another topic still from past questions extracted from NABTEB, NECO, and GCE. Okay, so 3 power of 3y plus 1 equals 81 power of minus y. So to deal with this, we'll have 3 power of 3y plus 1 equals 81 power of minus y. So this is already in base of 3. I can move 81 to also be in a base of 3 so that it will rhyme with the left hand side. And once it rhymes with the left hand side, I can easily cancel out and get what I want to get. So here I can write that 3 power of 3y plus 1 equals 81 means 3 power of 4, because 3 times 3 is 9, times 3 is 27, times 3 is 81. When you multiply 3 by itself into 4 times, you are getting 81. Then raised to power of minus y. So this is now 3 power of 3y plus 1 equals 3 power of 4 times minus y will give us minus 4y. So that 3 can cancel out 3. We shall have that 3y plus 1 equals minus 4y. Now to get the answer finally, let me move this negative 4 to this side and move the 1 to the right hand side. So we shall write that 3y plus 4y, it is negative here, coming here it turns to positive, equals plus 1 moving over is now negative 1. So that 3y plus 4y is 7y equals minus 1. Now to get rid of this 7, I will divide both sides by 7 so that I can get a value for my y. So divide by 7, divide by 7, 7 cancels out. Y is now minus 1 all over 7. And that's just the answer for our y. So this is a question that came out from NECO GCE 2019. So let's take another one from Logarithm this time around. All right, the fourth question for today, it says log 81 base 3 plus log 27 base 3 minus log 243 base 3. This is a NABTEB question 2009, a theory question. Log 81 base 3 minus log 27 base 3 minus log 243 base 3, and we are asked to simplify this. Now, if you remember the laws of logarithm, you will find out that whenever you see addition sign, you are multiplying, and whenever you see the subtraction sign, you are dividing, provided that all of them are given in the same base. If they are not given in the same base, it means that you cannot just apply the law immediately. You must do something to make them to be in the same base, or you solve independently. So we are lucky here, all of them are in the same base. So let's just write out that log 81 in base 3 plus log 27 in base 3 minus log 243 in base 3. Now, since all of them are in log 3, I can factor out log 3 here. So I'll be having 81 times, because I am seeing plus, I will multiply by 27. C minus, I will divide by 243. That's just it. So all of them are given in base 3. So I'll have log base 3. Then 81 plus implies times, and minus implies division. So let us simplify this. Do you know that 81 can divide itself to give us 1? When 81 divide 243, we are having just 3. Now 3 divided itself is 1. 3 divided 27 is 9. So all these things will turn into log 9 to base 3. Because 81 divided itself is 1. 81 divided 243 is 3. Then 3 divided itself is 1. 3 divided 9. 3 divided 27 is 9. So we have log 9 to a base of 3. But we shouldn't leave it here. We can simplify further. This 9 can be written as 3 power 2. So I have to express 9 to look like my base so that they will be in 3 and 3. Then according to the laws of logarithm, any power can climb to the back. So this here is now equivalent to 2 will climb to the back. I will have 2 log 3. And log 3 base 3 means 1. Any logarithm that is equivalent to the base is 1. Log AA is 1. Log BB is 1. Log 10 is 1. Therefore, log 33 is 1 according to the laws of logarithm. Hence, we have it as 2 multiplying 1 because this will turn to 1. So 2 times 1 will give us 2. So the whole of this question is just equivalent to 2. So that's just logarithm. Just know that in logarithm, if you are seeing addition sign, you are multiplying. If you are seeing subtraction sign, you are dividing. So if you need to go back and refresh your mind on the laws of logarithm, even indices that we just finished dealing with. So let's take another one. All right, so we have log 2m squared plus 5m minus 2 to a base of 10 equals 1. This question is extracted from NECO 2019. Okay, so let's rewrite the equation. We have log in base 10 of 2m squared plus 5m minus 2 equals 1. The idea is to make the base in the left hand side and right hand side to be the same thing. But here we are not having any logarithm. We can write 1 as a logarithm in base 10. So I can write this as log 10 into 2m squared plus 5m minus 2 equals log 10. Because log 10 is equivalent to 1. I want them to be the same thing, to be in the same logarithm. If this is in base 3, for instance, I will call it log 3 because log 3 is still 1. If it is in base 4, I will call it log 4 because log 4 is still 1. So the base it is into will determine what you are going to write here. Assuming this is 2, for instance, you have to write log 100 because 100 means 10 power 2. So that 2 can climb to the back and log 10 will now become 1. You have 2 back. If it is 3, you write log 10 1000 and so on and so forth. That's just the idea. Okay, so coming here, having written this, log 10 can immediately cancel out log 10, so that we shall have 2m squared plus 5m minus 2 is equivalent to 10 because there is a 10 left behind here. Let me bring this 10 to this left hand side. We shall have 2m squared plus 5m minus 2 minus 10 equal to 0. When this 10 comes into this place, it will change to minus, and nothing is left at the left hand side here again, so it becomes just 0. Okay, so collecting like terms, we have 2m squared plus 5m minus 12 is 0 because minus 2 minus 10 is minus 12. This is now a quadratic equation which we can factorize. So to factorize this, I will take the term which is the highest power of the quadratic equation to multiply the constant. So when I take 2m squared to multiply minus 12, I will have minus 24m squared. This is what is giving me. So if you want to factorize a quadratic equation, just take everything you are having here, 2m squared, and multiply your constant. And my constant here is minus 12. So when 2m squared multiplies minus 12, I will get minus 24m squared. Now ask yourself, what two numbers will you times to get minus 24m squared? And when you add the same two numbers, you get plus 5m. Okay, so what of, let's take 12. 12 and 2 will give us 24, but cannot give us 5. 8 and 3 can give us 24. Yes. So we have 8m, 3m will give us 24. But we need a negative value. So if I put negative here and this one as positive, you will see that 8m minus 3m will give me my 5m. And 8m times minus 3m will give me minus 24m squared. Therefore, I can write that 2m squared. Seeing this 5m, I will replace this 5m with 8m minus 3m, because 8m minus 3m will give me my 5m. So I write plus 8m minus 3m minus 12 equal to 0. So we factorize the first two terms here. The common item here, or the common factors, is 2m. So if I factor out 2m here, because 2 can divide 2 of them and m is common, this divide this will give me just m, plus 8m divide 2m will give me 4. So here, if I factor out minus 3, because minus 3 can go into 2 of them, minus 3m divided by minus 3 is just m. Minus 12 divided by minus 3, minus minus is plus 4, equal to 0. You must ensure that the items in the two brackets are the same thing. If they fail to be the same thing, it means that there is a problem somewhere else. You go and fish out the problem and adjust it. So factor out, this is common, you factor it out. So I factor out m plus 4. When I factor out m plus 4 here, I am left with 2m. Coming to this side, I'm left with minus 3, everything equal to 0. When two products are giving you 0, it means that either one of them is 0 or both of them are 0. For you to get 0 as a product, you must suspect that either one of the numbers you are multiplying together is 0 or both of them are 0, because you are getting 0. Because for a product of 0 to be got, it means that one of the members you are multiplying is 0 or both of them are 0. So I can now write either m plus 4 is 0, plus 4 coming here we turn to minus, so m is minus 4, or 2m minus 3 is 0, 2m is 3, when minus 3 crosses over is 3. So to get m, I will divide by 2. So m will give me 3 over 2. And 3 over 2 is the same thing as one whole number, 1 over 2. Therefore, m is minus 4, or one whole number, 1 over 2. These are the values of m in this particular equation, logarithm equation. You can see that one topic can lead to the other in mathematics. You've seen how logarithm led us into quadratic equation. That is why it is very, very important that students should be versatile in whatever they do, because you might learn logarithm very well and you don't know quadratic equation. Logarithm can lead you into quadratic equation and you'll be 10 stops along the line. Okay, so let's take another question in sequences now. Next question we have here is a question that came out in NABTEB 2005, and it is under sequence, the GP, geometric progression. So we are told that the system of a GP is 1215. If the common ratio is 3, find the third term. So common ratio R is 3 according to the question. We are asked to get the third term, but you know that Tn, that is n term of any geometric progression, is given by Arn minus 1, where A is first term and R is the common ratio, N is the number of term you are talking about. But in this question, there is nothing like first term. The first term is not given. So before I can get the third term, I must need to know the first term. Lucky enough, an information is given on the system. So let us see if this information about the system can help us to get the first term, so that we can substitute it here to get the required third term we are asked to get. Then T6 will now be A times R, common ratio is 3, I'll write 3, sin n system minus 1. But we are told that this system is equal to 1215, hence A times 3 power of 6 minus 1 is 5 equals 1215. Okay, now this is now A times 3 power of 5 will give us what? Multiply 3 by itself into 5 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is 243 equals 1215. Okay, so now to get A, I will divide both sides by 243 so that the value of A can be got. 243, 243. This cancels out. So A will give me, this divided by this should be around 5. So it will give me 5. So if I divide 1215 by 243, I'm getting 5, which means the first term is 5. And we've already known that the common ratio R is equivalent to 3. With this information, we can now answer the question that said we should get the third term. So T3 will now be, look at the general formula, A, which is now 5, multiplying R, which is now 3, power of n, T3, I have 3, minus 1. A is 5, you can see, times R, which is 3. Power of n, they say third term, n is 3, then minus 1. So T3 will give me 5 times 3 power of 2, because 3 minus 1 is 2. So T3 will give me 5 times 3 power of 2 is 9. And finally, 5 times 9 will give us 45. So you can see that the answer is just 45, as the case may be. All right, let's take one more question before we conclude. So finally, this is a question that came out in 2008, NABTEB, and it is under sequence though arithmetic progression. So we are told here that if minus 8, x, y, and 19 form an arithmetic progression, that we should find the values of x and y. So we have minus 8, x, y, and 19. You can see that this is the first term, second term, third term, and fourth term. So we just need to get the second term and third term. They are the values of x and y. Okay, but before I get the second and third term, I need my first term, which I have known as minus 8, and the common difference d. The common difference is not revealed, so let us get the common difference using the fourth term, because the fourth term is 19. You know that Tn, the n term of any given arithmetic progression, is equal to a plus bracket n minus 1d. Therefore, T4 will now be a, which is minus 8 plus n, number of terms. How many terms? 1, 2, 3, 4. The fourth term, 4 minus 1, bracket d. I don't know. But you know that all these fourth term is equivalent to 19. So you can say equal to 19, because the fourth term is 19. So minus 8 plus 4 minus 1 is 3. 3 times d is 3d, equal to 19. I'll solve from here. Minus 8 will come to the right hand side, it will turn to plus. So have 3d equals 19 plus 8. 19 plus 8. So 3d equals 19 plus 8 is 27. So I'll divide by 3. So the common difference is just 9. That's the common difference, 9. So if I want to get the value of x, x is T2. And T2, the formula is just a plus d. Okay, or you use the general term here, because if I put 2 here, 2 minus 1 is 1. 1 times d will give you back your d. That's why I said a plus d. T2 is equal to x. So T2, which is equal to x, will now be a. My a is minus 8 plus d, which is 9. So minus 8 plus 9 will give us 1. So x is 1. Let us get y. Y is T3. T3 is a plus 2d, because if I put 3 here, 3 minus 1 is 2. 2 times d is 2d. and A is also minus 8. So T3, which is Y, is equivalent to minus 8 plus 2 times D. The common difference is 9. So Y will give me minus 8 plus 2 times 9 is 18. And minus 8 plus 18 will give me 10. Therefore, X is 1 and Y is 10. At this juncture, we are coming to the expiration of this lesson. Kindly throw your questions and it must be rectified. All right. So if you want further studies, you can lay your hands on New General Mathematics, NECO and WAEC past questions, and NABTEBs. You can go online via google.com and search NABTEB NECO past questions PDF. You can download them and digest them. You may even see the solution to some of these questions. For further contact with the teacher, kindly get me via this number 07068394063. I am still your teacher, Mr. Chidiebube Esomnofu from Community High School, Ibariam. Thank you.